the most important applications of Newton's law is the inclined plane. What is an inclined plane? Here we have an inclined plane. The inclined plane is inclined surface making an angle with the horizontal, the table, and we place on this inclined plane a block. In order to prevent the block from sliding down along the inclined plane, we attach it to a rope connected to a stand. What are the forces acting on this block? We have the weight vertically downward perpendicular to the surface of the table. We have the normal reaction perpendicular to the inclined surface, and we have the tension T along the rope, which is parallel to the inclined surface. We measure the mass of the block by using a digital balance. The mass of it is equal 100 grams. This is the sketch of the inclined plane. Here we have the inclined surface and here the horizontal surface. We put on this inclined plane the block attached to the rope to this stand. Now we have to calculate the angle of the inclined plane, this angle. How can we calculate this angle? We measure the height of it, which is 24 centimeters, and the length of the inclined plane here is 60 centimeters. To calculate the angle alpha, we write sine alpha equal opposite over hypotenuse, which is equal to 24 divided by 60 equal 0.4. To find the angle alpha, we find sine minus 1 to 0.4, which is equal to alpha. Alpha equal to 23.57. In order to find the weight of the block, we can calculate the weight by using W equal mass times the gravity. The mass of the block is equal to 100 grams. We divided by 1000, which is equal to 0.1 kilogram, times the gravity, which is 10 Newton per kilogram, which is equal to 1 Newton. So the weight of the block is equal 1 Newton. The forces acting on the block are three forces acting here. Now we have the weight, which is vertically downward, perpendicular to the horizontal surface. This is the weight W. And the normal reaction perpendicular to the surface of the inclined plane. This is N, the normal reaction. And the third force is the tension force parallel to the inclined surface. The three forces acting on the inclined plane, the weight, the normal, and the tension. One of the three forces is given, which is the weight. As we calculate it, it's equal to 1 Newton. And now we have to find the magnitude of the tension T and the normal N. How can we calculate the two forces here? Since the block is at rest, so we apply Newton's first law. Sigma F equal to 0. The sum of all forces acting on the block is equal to 0. The three forces acting here is the weight plus the normal plus the tension equal to 0. Since the forces are vector quantities, so we add them by projection. In case of inclined plane, it's convenient to use the x-axis parallel to the inclined plane, like this. This is x prime, and the y-axis is perpendicular to the x-axis, perpendicular also to the inclined surface. The tension force is along the x-axis and the normal reaction is along the y-axis, while the weight is not along the x-axis nor the y-axis. So we have to project, we have to find the components of the W. We have the WY, this component along the y-axis, this WY, and we have the second component along the x-axis. This is the component of the weight along the x-axis, which is Wx. So we can see that the weight has two components, the Wx and Wy. Now, the angle alpha here, the angle alpha, which is equal to 23.57, is the same as the angle alpha here between WY and W. The same angle from the geometry of the figure. You can see the triangle, the big triangle, and the small triangle. These two triangles have the same angle alpha from the geometry of the figure. Sine alpha, if we take sine alpha is equal to the opposite. This side is opposite to alpha, the same as Wx, equal Wx over W. Implies Wx equal W sine alpha is equal to M times G sine alpha. And if we take the same angle, but the cosine alpha is equal to the adjacent to the alpha, this side adjacent to alpha, which is Wy over W equal, implies Wy equal W cosine alpha equal M times G cosine alpha. Now, what we can conclude now? We can conclude in case of inclined plane, we have Wx is equal to mg sine alpha, Wx equal mg sine alpha. This is very important formula. Yani the x component of the weight is equal to m times g sine the angle alpha, and Wy equal mg cosine alpha, m times g times cosine the angle alpha. The projection of the forces along the x-axis, we project along the x-axis. The projection of the weight is Wx, this is the projection, but it is opposite to the x-axis. So we write minus Wx plus the normal reaction is perpendicular to the x-axis, so there is no projection, is equal to 0. And the tension is along the x-axis in the positive direction, we write plus T equal to 0. Now, minus mg sine alpha plus T equal to 0. The tension T is equal to mg sine alpha equal to 0.1 times 10 times 0.4 equal 0.4 Newton. This is the magnitude of the tension T equal 0.4 Newton. In order to calculate the magnitude of the normal reaction N, we will project along the y-axis. Project along the y-axis. The projection of the weight along the y-axis is Wy. Is it positive or negative? We look here. Wy is opposite to the y-axis, so it is minus Wy. Plus N is along the y-axis in the positive direction, plus N, plus the tension. The projection of the tension along the y-axis is equal to 0. Plus 0 equal to 0. Now, the normal reaction N is equal to Wy equal to mg cosine alpha, N equal mass 0.1 times g is equal to 10 times cosine the angle 23.57 is equal to 0.91 Newton. This is the normal reaction N.